Good morning. I'm Hirotaka Suzuki, an associate professor of Kobe University, Japan. My specialty is lighting, environment engineering, and descriptive geometry. Today, I will have two lectures. The title of the first lecture is History of Andon, Japanese traditional lampstand and basic laws for illuminance. Before starting my lecture, I would like to introduce some histories of academic exchange between Vilnius Gediminas Technical University and Kobe University. In March 2010, Dr. Daiva Mektenian visited my office. This was the first point of our cooperative activity. We discussed about further cooperation in the field of engineering graphics education. In November 2013, I visited Daiva's office and met Dr. Rimantas Berbisius, Dean of the Faculty of Fundamental Sciences, to discuss about establishment of academic exchange agreement. In August 2014, I and Daiva met again for preparation of engineering graphics education workshop, and in November we held the workshop in Brussels. Finally, I and my colleague Dr. Odaka visited VGTU in the last November to meet Dr. Antanas Senis, Vice Rector of VGTU, and Dr. Rimantas Berbisius. And I and Dr. Odaka also had lectures for students and staffs of VGTU. Through these activities, we concluded academic exchange agreement of faculty level between Faculty of Fundamental Sciences, Vilnius Gediminas Technical University, and both Graduate School of Engineering and Graduate School of Human Development and Environment, Kobe University, in March 2014. And in February 2015, we concluded MOU. Based on these agreements, we are now trying to start lecture exchange using lecture video. It is great pleasure for me to start the first lecture exchange. In the first video, I will explain history of Andon, Japanese traditional lampstand, shapes of Andon, and basic laws for illuminance distribution. Let's start from history. Nowadays, artificial light by electricity is highly widespread in Japan. Though the light by fire was exclusive artificial light before invention of an arc lamp by Humphrey Davy in 1808 and an electric incandescent lamp by Thomas Edison in 1879. After these inventions, the most popular electric lamp changed from incandescent lamp to fluorescent lamp and LED lamp. However, artificial light for human being was light by fire for a long time before these inventions. As fire is especially weak against wind, fire should be surrounded by paper shade. When people wanted to take out light source, then they had to envelop the fire in the paper shade. Later, portable lamps with oil fire were called chochin, and stationary lamps with candle fire were called Andon in Japan. The paper of Andon is also serving as light diffuser. Andon can send soft and non-directional light to surrounding area. Today, light by electricity does not need windbreak. Lampshade is serving as an adjuster which controls spatial distribution of luminous intensity. The shapes of almost all traditional Andons are primitive figures, including pyramid, prism, cone, cylinder, and sphere. With regard to material of shape, diffuse material generates soft light, and specularly transmitting material generates brightly shining light. Then, I would like to explain basic laws for illuminance distribution. Besides spatial distribution of luminous intensity from light source, brightness on Andon itself is also significant for aesthetic attraction of Andon. Then, how brightness on the surface can be decided. When you want to calculate illuminance of vertically incident light from point light source, value of the illuminance is in inverse proportion to square of distance from light source to the point, according to inverse square law of illuminance. And when you want to calculate illuminance of non-vertically incident light from point light source, value of the illuminance is in proportion to cosine of incident angle according to cosine law of illuminance. Considering these basic laws for illuminance distribution, you can easily understand that uniform illuminance distribution will appear if you put point light source at the center of spherical lampshade. It is very difficult to discriminate sphere from circle with the uniform illuminance distribution without additional geodesic lines. Or even lampshade of cylindrical shape cannot be easily recognized its shape. Then, how should we do to help recognition of shape of lampshade? Illuminance distribution is decided by directional luminous intensity, shape, and distribution of reflectance or transmittance. If we can add texture on the surface of lampshade by shape or transmittance distribution, then shape recognition becomes easier. As people in Japan do not like rapid change of transmittance distribution traditionally, we would like to change shape by giving non-flat texture to realize non-uniform illuminance distribution. In the second video, I would like to explain origami paper folding method for non-flat texture. Thank you for watching the first video.